Okay, so we're still looking at the sets of numbers, and under sets of numbers, today we're looking at irrational numbers in details and surds. The last lecture we had, we looked at rational numbers where we said these are numbers, the rational numbers, these are numbers that can be expressed in the form A over B, where A and B are members of integers, and B should not be equal to 0. And then apart from that, we also discussed that this A and B are supposed to be in their lowest terms, meaning they are co-prime factors. So this is what we discussed last time. This is just the definition of rational numbers. So this is the definition of rational numbers. So today we're looking at irrational numbers, and then after looking at irrational numbers, we also look at surds. Yeah, so irrational numbers, as we discussed at the beginning of sets of numbers, these are just numbers that okay, we said they are just opposite to rational numbers. So meaning any set that is outside the set of rational numbers is called a set of irrational numbers. Okay, so in other words, a set of, or rather an irrational number is just a number in a decimal form whose block of digits neither terminates nor repeats. Remember, when we are looking at rational numbers, we said these rational numbers can either terminate or they can repeat. So terminating rational numbers, we said these are an example that the example that I gave was 1 over 2. So 1 over 2 is a terminating rational number because when you divide this 2 into 1, you get 0.5. So this number has an ending. And then we also have repeating rational numbers. Repeating rational numbers are numbers like maybe you have something like 3.125, and then this 125 are repeating. So you have 3.125, 3.125, which can also be written as 3.125, 125, 1, 2, and 5 are repeating. So it keeps on going like that. So these are repeating rational numbers. So now today we're looking at irrational numbers. So any number that does not terminate, and that neither terminates nor repeats is called an irrational number. So anything that does not terminate or it does not repeat, it's an irrational number. So some examples of irrational numbers have been given. One of the examples is this one here, and then the other examples are here. We also have other irrational numbers that have not been written here. So that's what it means when you talk about irrational numbers. So irrational numbers are just numbers that do not terminate nor repeat. Okay, so these are some of the examples of irrational numbers. We have the square root of 2, we have the square root of 3, we have the square root of 5 as well. Okay, so let's take a look at how you can know that this is an irrational number. How can you prove that root 2 or root 5 or root 5, or root 3 or root 5 or any number? How can you prove that this number is an irrational number? So we use the method that is called a contradiction method. So here we have a question which says prove that the root of 2 is an irrational number. So how can you prove this? We use a method known as the contradiction method. Contradiction method. So this is the method that we're going to use. So how do you use this method? So we're going to make an assumption. We're going to assume that the root of 2 is, we're going to assume that the root of 2 is, okay, let me just write even the word assume. Okay, so the first step we're going to do is to assume that the root of 2 is a rational number. So when you make this assumption, when we make this assumption that the root of 2 is a rational number, so we know to say a rational number can be expressed in the form A over B, and then where A and B are members of integers, and then B should not be equal to 0. Then apart from that, we also have to know that A and B are in their lowest terms, meaning they are in their smallest term. There is no number that should be that should enter into A. There shouldn't be any number again that should enter into B. Meaning A is in its lowest term, B is also in its lowest term. In other words, we say A and B are co-prime factors. So A and B are co-prime factors. So this is what it means when we talk about contradiction method. So we'll make an assumption to say the root of 2 is a rational number. So we know that a rational number is a number that can be expressed in the form A over B, and then A and B are members of integers. B should not be equal to 0. A and B are co-prime factors. All right, so from there, let us now try to see if truly this root 2 is a rational number. This is just an assumption, but let's try to use this assumption to prove. So what can we do from this step? We're going to raise both sides to the power 2 in order to get rid of this square root. So in order to get rid of this square root, we're going to raise both sides to the power 2. So after raising both sides to the power 2, means that the root of 2 raised to power 2 will simply just give us 2, and then A raised to power 2 give us A squared, then B raised to power 2 give us B squared. So from there, we can now cross multiply. So when you cross multiply, we're going to have 2B squared is equal to A squared. And then we can flip this, we can say A squared is equal to 2B squared. So when you look at this statement here, so this statement, when you look at it, it means that for you to find A squared, it means that you have to multiply 2 times B squared. This is what it means. For you to find A squared, you have to multiply 2 times B squared. This is what this statement means. So what does this mean? It means that 2 is a factor of A squared. So it means that A squared means that A squared is divisible by 2. It means that A squared is divisible by 2. And then after knowing that A squared is divisible by 2, you can also conclude that since A squared is divisible by 2, it means that even the square root of A squared is also divisible by 2, which is A. So say even A is also divisible. It's also divisible by 2. So after doing that, it means that if A is divisible by 2, this A is divisible by 2, it means that for you to find A, you have to multiply 2 times K for you to find A. So let me write it this way. So for you to find A, we're saying A can go into 2. So if A can go into 2, we don't know how many times, but we know that, 2 can go into A, and then, but we know to say 2 can go into A squared how many times? B squared times. But we don't know how many times 2 can go into A. So in other words, let me try to explain this statement here, just this part here. Maybe that's when you get the concept properly. So this part is simply just, let me change the color. So this part here is simply just, so I'm trying to explain this part here. So this part is simply just A squared is equal to 2B squared. So if I want, I can write this as A squared over 2 is equal to b squared. So what this statement means is that when I divide a squared by 2, the answer that I'll get is b squared, sorry. And then we're also saying that this a, the square root of a squared, which is a, is also divisible by 2, which implies that for us to find a, we have to multiply 2 by a certain number. This is what it means. If I say 2 can go into a, means that if I say 2 can go into a, it's just the same as writing this. But do I know the answer that I'm going to get after dividing 2 into a? I don't know. So I'm just going to introduce another variable. Some books they use m, some books they use k, some books c. It depends. You can use any letter you want. So in this case, I'm using k. Yeah. So I'm saying if I divide a by 2, I'm getting the answer which I don't know, which is just k. So if I cross multiply here, I'm going to have, if I cross multiply, I do the cross multiplication here. I'm going to have a times 1, I'm going to get a, and then is equal to 2 times k, I'm going to get 2k. So this is what this is the statement I've just written there. So this is the statement, a is equal to 2k. Okay. So from there, okay, so from there, let me continue. Okay, so from there we can now proceed. So in this expression there, while there's a, I'm going to put 2k. So, okay. So in that expression, while there is a, so in this expression, which is a squared is equal to 2b squared. While there is a, I'm going to put, while there's a, oh wait, okay. So while there is a, I'm going to put 2k. So here while there's a, I'll put 2k. Then this is squared is equal to 2b squared. Okay. So when I raise this 2k to the power 2, I'm going to have 4k squared is equal to 2b, 2b. Okay, so I'm going to have 2b squared given this side. So this side I'll have 2 to the power 2, which is 4k to the power 2k squared. And then 2b squared. This is what I'm going to have. So from there, I know that I can divide both sides by 2. Then I'm going to have my b squared being equal to 2k squared. So even this statement, when you look at it, this one, it also means that for me to get, it also means that 2 can also go into b squared. How many times? K squared times. How do I know that? Because I know that this statement can also be written as b squared over 2 is equal to k squared. When I divide both sides by 2, I'm going to have b squared over 2 is equal to k squared. So this simply implies that when I divide 2 into b squared, my answer I'm going to get is k squared. So this means that 2 can go into b squared. How many times? K squared times. So I'm going to say b squared is divisible. If you want, you can say 2 is a factor of b squared. Or if you want, you can say b squared is divisible by 2. If b squared is divisible by 2, it means that even b is also divisible by 2. So now, when you look at these two statements, this one here, when you look at these two statements, you have this one here, you also have this other statement here. When you look at these two statements, don't they contradict with this statement here? Because we said A and B are supposed to be co-prime factors. So if A and B are supposed to be co-prime factors, it means that there shouldn't be any number that should go into A and B. But according to what we've discovered that 2 can go into A and 2 can go into A squared. The same applies to this part. 2 can go into B, which implies that, or which contradicts with the statement that A and B are supposed to be co-prime factors. So you can conclude by saying, therefore, A and B are divisible. Therefore, A and B are divisible by 2, which which contradicts with the fact that A and B are supposed to be co-prime factors. With the fact that A and are co-prime factors. So that's what that's how you can conclude that. Yeah, so that's why this one is called the contradiction method. You just have to find any fault, anything that contradicts with the definition of a rational number. So what we have written here is simply just a definition of a rational number. So we assumed at the beginning that the root of 2 is a rational number. But according to what we've discovered that A can go into, 2 can go into A, 2 can also go into B. But according to the definition of rational numbers, we said A and B are supposed to be in their lowest terms. So we've concluded to say we've concluded to say the root of 2 is not a rational number, it's an irrational number, because it consists of numbers that can go into both A and B, meaning this fraction A over B is divisible by 2. I don't know if the explanation is clear there. Let me know if we can proceed to the next question. Okay. So I think we can proceed. Yes, Rafa.
So I'm behind. I think I joined direct, so this is the reason why I'm behind.
Oh,
yes, Rafa.
Okay, let me just go through it very quick, and for the sake of everyone else who joined late, let me just go through it quickly.
Thank you.
Yeah,
Yes,
and by the way, any day, I think if not tomorrow, then maybe Monday, depending with your response, we'll start meeting for computer science. We'll start meeting for ICT or ITC, depending with how you want to call it. Okay, so we'll start meeting all those that have paid for it. They are already in the new group for ITC. Okay. All right. Okay, so let me just go through it quickly, because if you don't understand this one, it will be very difficult for you to understand the other questions. So I've just decided to restart the question. Okay, so we said, the question is asking us to prove that the root of 2 is an irrational number. So how do we prove this question? We assume, or rather we use a method that is called the contradiction method. So we use contradiction method. So according to its the name of the method we're using, contradiction, meaning something has to contradict with one of the statements that we're going to make. Not really the statements that we're going to make, but one of the definitions of the rational numbers. So in short, we're going to assume that the root of 2 is a rational number. So we make an assumption. We assume that the root of 2 is a rational number. So they want us to prove that the root of 2 is irrational. But how do we prove that? We use contradiction method. So for contradiction method to use to work, it means that you need to assume the opposite of what you've been told. That's how this method works. So the opposite of an irrational number is a rational number. So we're going to assume that the root of 2 is a rational number. So after making this assumption, let us define what a rational number is. So a rational number, if the root of 2 is a rational number, it means that this root 2 can be expressed in the form a over b, where a and b are members of integers. And then this is letter z, symbolizing integers, are members of integers. And then a and b are co-prime factors, of course, but before we write that, we can first say b should not be equal to 0. So if we're solving the question, if we're solving this question and at one point we discover that either a or b is not a member of integers, we find something that is not an integer, it means that the answer, it means that from there we can conclude that that part contradicts with the fact that a and b are supposed to be integers. And if at any point we discover that b is equal to 0, because we know that for this to qualify to be a rational number, b should never be equal to 0. So in the process of solving, if we discover that b is equal to 0, we can conclude that this is an irrational number. It's not a rational number, because for this to be a rational number, b should never be equal to 0. And then we also have to make sure that a and b do not have factors. In short, a and b shouldn't have factors. So in other words, we say a and b are co-prime factors, meaning they are in their lowest term. Co-prime factors, meaning that they are in their lowest term. Hence, if at any point as we are solving, we discover that there's a number that can go into a, or there's a number that can go into b, or if there's a number that can go into both a and b, we can conclude from that point to say, root 2 is not a rational number, because a and b, its value of a and its value of b has a factor, because we know to say for this to qualify to be a rational number, it doesn't need to have a factor. It doesn't need to have any number that can go into its a and b. Okay, so let's start. So we have the root of 2 is equal to a over b. So from there we can square both sides to get rid of the square root, and then when you square this side, we're going to get 2. When we square the other side, we get a squared over b squared. From there, we can cross multiply. So when you cross multiply there, we're going to have 2b squared is equal to a squared. So from there, we can now conclude to say, because when you look at this statement, we're saying when we multiply 2 times b squared, the answer that we're going to get is a squared. It means that 2 can go into a squared. How many times? B squared. Because when you divide 2 into a squared, we're getting b squared. So this statement can also be written as a squared divided by 2 is equal to b squared. This is how we can write it if we cross multiply there. So which simply means that if we divide a squared by 2, we're going to get the answer to be b squared. This implies that 2 is a factor. I'm going to use another statement. If I want, I can say a squared is divisible by 2, but I can also say 2 is a factor. 2 is a factor of a squared, which implies that even A, which implies that 2 is also, a factor of A. That is what it means. So if 2 is a factor of A squared, it means that 2 is also a factor of A. So from there, we can tell to say if 2 is a factor of A, it means that this statement, the last statement here, it simply means that 2 can go into A. How many times? We don't know. So we can say 2 can go into, or let me write it like this, sorry. So we can say 2 can be, A can be divided by 2, and then the answer that we get after dividing A by 2, the answer will simply just be K. In other words, 2 can go into A how many times? K times, because we don't know how many times 2 can go into A, since A is just a variable there. It's just any number. Yeah, it's just any number that is a member of integers. So we don't know the answer after dividing A by 2. That's why we put K there. You can put any variable there. So this, when we cross multiply, can also be written as, when you cross multiply there, we can have A is equal to 2K. So from there, we can now, from there, we can now replace this A in this expression there. So we can replace this A in this expression. So while there's A in this expression, we're going to put 2K. So we have 2B squared is equal to, 2B squared is equal to, while there is A, we put 2K. So this A is squared, so we have 2K squared. So this side we have 2B squared is equal to, when you open the brackets there, I'll get 4K squared. So when you divide everything by 2, we'll get K squared is equal to, we'll get 2K squared, because 2 into 4 will get 2. So we'll remain with 2K squared is equal to B squared. So from there, we can conclude, from this point, we come there. So we can also conclude that for you to find B squared, you multiply 2 times K squared. So this also implies that 2 is a factor. So 2 is a factor of B squared. And since 2 is a factor of B squared, it means that 2 is also a factor of B. So this, when you look at these two statements, this statement here and this statement, these two statements contradicts with the fact that A and B are supposed to be co-prime factors. So when we say co-prime factors, it means that there shouldn't be any number that should go into A or B. But what we've discovered that 2 can go into A and 2 can also go into B, which contradicts with our statement here that for root 2 to qualify to be a rational number, A and B are supposed to be co-prime factors. Hence the contradiction. So we can say, so we can conclude by saying, I think, let me just write the conclusion on top here. So we can say, since A and B are, or if you want, you can, to shorten your statement, you can say, since 2 is a factor of both A and B, since 2 is a factor of both A and B. Since 2 is a factor of both A and B, this contradicts with the fact that, so this contradicts with the fact that A and B are co-prime factors. Then you say hence the root of 2 is an irrational number. Yeah, so that's how you conclude. So it's just as simple as drinking water. It's just, that's how simple it is.
Sir.
Yes, this is simple. Okay, so I think we can proceed. We can go to the next question. Okay.
When the class is quiet, sir, then
Huh?
I'm saying when the class is quiet, it means something also, sir.
Okay, this is being recorded, so I'll post the video. So what it means, if I say I'll post the video, it means that you can repeat the same video even 5 times. Just watching it, at one point you understand. All right, so let's look at the next question.
Okay.
Yeah, this one is quite
So you
simple.
can understand if you get the concept.
Huh?
As I'm saying, you can only understand if you get the concept. We are
Yeah.
behind, sir.
On the same question.
Yes.
Okay, but okay, for this question, hello.
So I think we proceed. You are going to share the video. I think you've explained twice. We'll be able to get the concept from that.
All right. Okay, so we move on to this question here. So this question is also simple. This one is quite even simpler than the other one, the one that was just from solving. So there are 2 methods, or there are 2 ways you can solve this one. So if you want, you can first prove that the root of 2 is irrational using the this method that I've shown you here. Then after proving that, and then you conclude by saying, after concluding that the root of 2 is irrational, and then you make another conclusion to say addition or subtraction of an irrational number and a rational number, because we know that 1 is a rational number. So you say addition of an irrational number and a rational number yields or gives an irrational number. So when you add a rational and so when you add a rational, so when you add a rational and an irrational, the answer is irrational. When you subtract a rational and irrational, whether you start with irrational or rational, it's still the same. When you subtract these, the answer will still be irrational. When you divide, when you divide the rational, when you divide irrational and rational, or irrational and rational, as long as you are dividing, the answer should give you an irrational. When you multiply irrational, as long as there's an irrational number there, it makes everything irrational. Yeah, so as long as you are adding, you are subtracting, you are dividing an irrational and the rational, you still get the answer to be irrational. That's what it means. So if you want, you can use this method. After proving that the root of 2 is irrational, then you conclude by using this, saying the addition of a rational number and an irrational number gives an irrational number. Hence, the addition of 1 and the root of 2, which is an irrational number, will give us an irrational number, meaning 1 plus root 2 is irrational. Okay, so this is one way you can prove that. And then the other way you can prove this is by assuming. Use contradiction again. Contradiction. So when you're using contradiction, it means that you're going to make an assumption again. You're going to make an assumption that, so we assume that 1 plus the root of 2 is 1 plus the root of 2 is a rational number. So when this is a rational number, it means that, yeah, so if this is a rational number, it means that it can be 1 plus the root of 2 can be expressed in the form A over B, where A and B are members of integers. And then B should never be equal to 0. Then A and B should be co-prime factors. So if we say co-prime factors, we mean that there shouldn't be any number that should be, or that should go into A and B. They are, in short, they are in their lowest term. So from there, we can take this, we can pick 1 plus the root of 2 and then solve it independently over B like this. So the link is about to cut, it's about to end. The meeting is about to end. I'm going to send another link that we're going to use to join. So from there, we can take this one to the other side of the equal sign, meaning we're going to have the root of 2 is equal to A over B minus 1. So when we simplify this, we're going to have the common denominator is B, and then we say B into B is 1. 1 times B, or 1 times A, the answer is A. And then this is 1. 1 into B, it's B. B times 1, the answer is B. So we can say let A minus B be equal to D.